Light interacts with matter during reflection, absorption, scattering, and transmission. Have you ever seen a cat's eyes glow in the dark when light shines on them? Cats have a special layer of cells in the back of their eyes that reflects light. This layer helps the cat see better by giving the eyes a second chance to detect the light. Reflection is one interaction of light waves with matter. Reflection. Light travels in straight lines as long as the material that the light travels through doesn't change. So a ray of light shining through air is usually straight. One way to change the direction of a light beam is by reflection. Reflection is the bouncing back of light rays when they hit an object. But light doesn't change directions randomly. Instead, it follows the law of reflection. The law of reflection. Light is reflected by surfaces the same way that a ball bounces off the ground. If you throw the ball straight down, it will bounce straight up. If you throw the ball at an angle, it will bounce away at an angle. The law of reflection states that the angle of incidence is equal to the angle of reflection. Incidence is the arrival of a beam of light at a surface. Figure 1 shows this law. Types of reflection. Why can you see your image in a mirror but not in a wall? The answer has to do with the differences between the two surfaces. A mirror's surface is very smooth. Thus, light beams are reflected by all points of the mirror at the same angle. This kind of reflection is called regular reflection. A wall surface is slightly rough. Light beams will hit the wall surface and reflect at many different angles. So the light scatters as it is reflected. This kind of reflection is called diffuse reflection. Figure 2 shows the difference between the two kinds of reflection. Light source or reflection. If you look at a TV set in a bright room, you see the cabinet around the TV and the image on the screen. But if you look at the same TV in the dark, you see only the image on the screen. The difference is that the screen is a light source, but the cabinet around the TV is not. You can see a light source even in the dark because light emitted by it is detected by your eyes. The tail of the firefly in Figure 3 is a light source. Flames, light bulbs, and the sun are also light sources. Objects that emit visible light are called luminous. Most things around you are not light sources, but you can still see them because light from light sources is reflected by the objects and then is detected by your eyes. A visible object that is not a light source is illuminated. Absorption and scattering. Have you noticed that when you use a flashlight, the light is dimmer the farther it travels from the flashlight? Partly because the beam spreads out and partly because of absorption and scattering, the light is weaker the farther it is from the source. Absorption of light. The transfer of energy carried by light waves to particles of matter is called absorption. When a beam of light shines through the air, particles in the air absorb some of the energy from the light. As a result, the beam of light becomes dim. The farther the light travels from its source, the more the light is absorbed by particles, and the dimmer it becomes. Scattering of light. Scattering is an interaction of light with matter that causes light to change direction. Light scatters in all directions after colliding with particles of matter or undergoing diffuse reflection. Light from the ship shown in Figure 4 is scattered out of the beam by particles in the fog. This scattered light allows you to see things that are outside the beam. But because light is scattered out of the beam becomes dimmer. Scattering makes the clear sky blue. Light that has shorter wavelengths is scattered more by particles of gas in the air than light that has longer wavelengths is. Sunlight is made up of many colors of light, but blue light, which has a very short wavelength, scatters more than any other color. So, when you look at the sky, you see a background of blue light. Light and matter. When light hits any form of matter, the light can interact with the matter in different ways. The light can be reflected, absorbed, or transmitted. You know that reflection happens when light bounces off an object. Reflected light allows you to see things. And you know that absorption is the transfer of light energy to matter. Absorbed light can make things feel warmer. Transmission is the passing of light through matter. In fact, without the transmission of light, you couldn't see. All of the light that reaches your eyes is transmitted through air and several parts of your eyes. Light can interact with matter in several ways at the same time, as Figure 5 shows. Types of matter. Matter through which visible light is easily transmitted is said to be transparent. Air, glass, and water are examples of transparent matter. You can see objects clearly when you view them through transparent matter. Sometimes, windows in bathrooms are made of frosted glass. If you look through one of these windows, you will see only blurry shapes. You can't see clearly through a frosted window because it is translucent. Translucent matter transmits light, but also scatters the light as it passes through the matter. Wax paper is an example of translucent matter. Matter that does not transmit any light is said to be opaque. You cannot see through opaque objects. Metal, wood, and this book are opaque. You can compare transparent, translucent, and opaque matter in Figure 6. Colors of objects. How is an object's color determined? Humans see different wavelengths of light as different colors. For example, humans see long wavelengths as red and short wavelengths as violet. And some colors, such as pink and brown, are seen when certain combinations of wavelengths are present. Color that something appears to be is determined by the wavelengths of light that reach your eyes. Light can reach your eyes after being reflected by an object, transmitted through an object, or emitted by an object. When your eyes receive the light, they send signals to your brain. Your brain interprets the signals as colors. Colors of opaque objects. When white light strikes a colored opaque object, some colors of light are absorbed and some are reflected. Only the light that is reflected reaches your eyes and is detected. So the colors of light that are reflected by an opaque object determine the color you see. For example, if a sweater reflects blue light and absorbs all other colors, you will see that the sweater is blue. Another example is shown on the left in Figure 7. What colors of light are reflected by the cow shown on the right in Figure 7? Remember that white light includes all colors of light. So white objects, such as the cow's white hair, appear white because all of the colors of light are reflected. On the other hand, black is the absence of color. When light strikes a black object, all of the colors are absorbed. Colors of transparent and translucent objects. The colors of transparent and translucent objects are determined differently than the colors of opaque objects. Ordinary window glass is colorless in white light because it transmits all of the colors that strike it. But some transparent or translucent objects are colored, such as the window in Figure 8. When you look through colored transparent or translucent objects, you see the color of light that was reflected by or transmitted through the material. The other colors were absorbed. Pigments and color. A pigment is a material that gives a substance its color by absorbing some colors of light and reflecting others. Almost everything contains pigments. For example, melanin is a pigment that gives your skin its color. Chlorophyll is the pigment that gives plants a green color. The light energy absorbed by chlorophyll is converted into chemical energy during photosynthesis. Some tree leaves have pigments other than chlorophyll, as Figure 9 shows. Color subtraction. Each pigment absorbs at least one color of light. When you mix pigments together, more colors of light are absorbed or taken away. So mixing pigments is called color subtraction. The primary pigments are yellow, cyan, and magenta. They can be combined to make any other color. In fact, every color in this book was made by using just the primary pigments and black ink. The black ink was used to provide contrast to the images. Figure 10 shows how the four pigments combine to produce many different